All right, today we're going to work on just one problem together, and then I'm going to let you guys try some problems on your own here. So there is quite a bit to solve in this problem. There are three things. We're going to solve for little w, which is this side down here, and we're going to solve for angle x, and we're going to solve for angle y. Now, where would you like to start? Well, how about let's start alphabetically and just start with w. So notice w is a side, and if we're going to do some trig, some sine, cosine, tangent, we needed to know an angle other than the 90-degree angle. And notice we don't have an angle to work with here. We don't have x or y. Now, there is a way around this particular problem in that we know two of the three sides of this right triangle. So we could use some old school Pythagorean theorem. All right, so let's do a little bit of old school stuff. This will prepare you really for the end of the chapter here, the chapter review that's coming up tomorrow. And so the hypotenuse, this will be my C side, and then the A and the B side, it doesn't matter which one's which, but I'll call the A side the W and the B side the 17. So with the Pythagorean theorem, we could have C squared equals A squared plus B squared. The C side is my 20, so 20 squared equals W squared plus B squared, 17 squared. And then we needed to convert what those numbers really were. So 20 squared, 20 times 20 in my calculator is 400. The W squared we leave, W squared. And 17 squared, 17 times 17 is 289. So then algebraically, we need to get that 289 over with the 400. So we'll subtract 289 over. So that now we just have the W squared all by itself on one side. And 400 minus 289 is, 111. And then how do we get rid of the square on the W square? Well, we square root both sides. And so the square root of 111, let's get our calculator here. So the square root of 111, square root 111 is 10.54. That 5 is going to bump that 3 up. So 10.54. So W is approximately 10.54. And so there's the side length for W. W is approximately 10.54. Perfect. Okay, now to figure out what x and y are, the angles. And so this is what we've been working with recently, is solving for angles using trig. And we can't use the Pythagorean theorem to solve for missing angles. The Pythagorean theorem only works with sides. And so we're going to need to label the sides that we have here. And plus we need to figure out, are we going to solve for x or y first? So I'm just, again, going to go alphabetically, and let's solve for x first. And let's label the sides that we have. Now, I would recommend just using the two sides that we were given at the beginning of the problem, the 17 and the 20. The 20 was the hypotenuse, and the 17 is the adjacent side. Now, I do know what the opposite side is down here. We just figured it out, but it was an approximate number. It wasn't an exact number. So if you want, you could use this 10.54, but my recommendation would be, let's just use the 17 and the 20. All right, let me erase this and get some room here. And so if I have an adjacent and a hypotenuse, what type of problem was that? Was that a sine, cosine, or tangent problem? And it's a cosine problem. So we'd set up the cosine of our angle, but we don't know what the angle is, x, is equal to the adjacent side, the 17, over the hypotenuse, 20. And so we need to figure out what x is. So we need to get x all by itself. So we got to get rid of this cosine. And so how did we get rid of cosines? What was the opposite of cosine? And that was our inverse cosine. We took the inverse cosine of the left side and the inverse cosine of the right side. And so that inverse cosine undid our cosine, and we were left with just x. And then we needed to type into our calculator the inverse cosine of 17 divided by 20. Approximately. And remember, our angles we're going to round to the nearest whole number. All right, so calculator. Inverse cosines. Remember, you got to press the second cosine. 17 divided by 20 in my parenthesis. And we get 31.7. That 0.7 is going to bump up our 1 to a 32-degree angle approximately. 32 degrees. So there's angle X. Now remember, to get the last angle, we could do another trig problem, but there is a more efficient way of doing it. We now know 2 of the angles in this triangle, and all 3 angles must add up to be 180. So angle Y is going to be equal to 180. We get rid of the 90. We get rid of the 32 that we just figured out. And so if we subtract those 2 angles from 180, then angle Y is going to be, 58 degrees in total. And now there's all 3 of my missing pieces, W, X, and Y. Now, one last final thing that I'm going to say here. Let's say you figured out that X was 32 and Y was 58, and you didn't use the Pythagorean theorem to solve for W. Now, what you could have done is you could have labeled W as the opposite side of our angle X, and you could have worked with opposite and hypotenuse and set up a sine problem, or you could have set up opposite with adjacent and set up a tangent problem instead. Either one of those 2 setups would have gotten you that W was around 10.54. It might be slightly different, but it's going to be pretty close to 10.54. So again, instead of the Pythagorean theorem, you could have set up a sine or a tangent ratio with this 32 degree to solve for W like we had the week prior. All right, good luck to you on your homework. You can let me know if you got any questions. Good luck.